the reason of this installation has been that the Bia Tano Forest Reserve is found within the middle belt of Ghana, and this forest is very unique in the sense that it behaves, because it's found within the transitional belt, it behaves more likely to the savanna zone kind of forest system, and then it also has some characteristics of the tropical rainforest kind of ecosystem. So with this forest being within the middle or the transitional belt of Ghana, it gives us a very rich kind of data for us to understand how our forest is really behaving, especially with those that might be in the northern savanna and also that in the southern tropical forest, rainforest.
The activity of the Bia Tano Forestation is expected to shed light on carbon cycling and more generally on the ecological feedback of tropical forests with respect to climate change, as re-echoed by the Intergovernmental Panel on Climate Change (IPCC). Experts emphasize that the sudden increase in atmospheric greenhouse gases concentrations caused by human activities contributes to global warming.
Currently, the lead scientist working on the carbon flux monitoring project that is under the Earth Observation Research Innovation Center.
Dr. Caleb Mensah is with the Department of Atmospheric and Climate Sciences and a researcher with the Earth Observation Research and Innovation Center at the University of Energy and Natural Resources.
We know that trees, through photosynthesis, are able to absorb a lot of this carbon dioxide from the atmosphere, and these carbon dioxide are part of these greenhouse gases that have a lot of this warming effect that we have been experiencing now. As such, we are unable to really determine the ability or how efficient these trees are able to really pull some of the carbon dioxide or sequester carbon dioxide concentration from the atmosphere.
He says the eddy covariance sensors installed on the 56-meter tower are critical to understanding how much carbon the forest captures, both seasonally and annually.
And to enable us improve upon our data, that's when it comes to the efficiency of these trees to really sequester carbon dioxide. Now the center is also embarking on this project whereby we are able to measure directly how much carbon is being sequestered by our tropical trees and how much and how efficient even they are under different climatic conditions. For instance, under warming conditions, are these trees going to really sequester the amount of carbon that we are expecting these tropical trees to? And even if they are doing it, at what rate should we be expecting that they are really sequestering the carbon? That's why we have this project, which is now situated within the Ahafo region at Bia Tano Forest Reserve, whereby we have mounted some eddy covariance sensors on the top of a 56-meter tower just to monitor the amount of CO2 concentrations that are being sequestered by these tropical African or Ghanaian trees, and then also it will be monitoring the fluxes of carbon within these forest trees and the atmosphere. And through that, we are able to know directly how much this carbon dioxide is being sequestered.
Data on evaporation and the exchange of greenhouse gases between the trees and the atmosphere will allow scientists to calculate the contribution of the forest to climate change mitigation and to better understand precipitation patterns in the area.
The reason why we use the eddy covariance technique is that it is the sensors are placed within the mixing layer of the forest canopy, and through that, because the air is mixing up with the carbon dioxide that might be present at the canopy level of the forest ecosystem, at least through the mixing, it's able to carry data into the sensor for it to measure the amount of CO2 concentration over the forest region at that particular time. So other studies that have used this same technique have told us that even this tropical forest, especially over the South American region, these tropical forests are not able to absorb so much carbon as we expect them to, because these mature trees over the years have sequestered a lot of carbon, and as such they rather emit because they die off. And these are primary forests that the trees have lived in the forest over years. So instead of they rather sequestering more carbon, they are very weak when it comes to the sequestration of carbon. However, when they die, they rather emit more of this carbon into the atmosphere. That's why when you are talking about the net carbon dynamic balance, they tend to now be more emitters of carbon than even they sequestering carbon. If we are able to understand how well they are really able to sequester carbon, then when we go for green planting, at least we know the kind of trees that are able to really sequester a lot of this carbon. Then we can know how well to plant most of these trees and how to even protect these trees from them going to extinction.
The establishment of the experimental eddy covariance research station is part of a joint scientific research collaboration between the Global Change Research Institute in the Czech Republic and the University of Energy and Natural Resources. The Ghana Tower is one of the few flax towers on the African continent to provide accurate data on the exchange of greenhouse gases between the atmosphere and the tropical primary forests. It will further strengthen the underlying greenhouse gas inventory management, measurement, reporting, and verification systems of Ghana's annual report to the Intergovernmental Panel on Climate Change.
Every year, Ghana, being a signatory to the United Nations Framework Convention on Climate Change, we are supposed to report straightly to the United Nations on how well we've been able to protect our forest, or how well we are contributing our role or in making sure that we are reducing the atmospheric concentration of carbon dioxide. And all of these data will also be given, or will go into the national pool and at least enrich our data, so that when we are now laying emphasis on the amount of carbon that our trees are sequestering, at least we can now mention figures, we can now attach figures for them to know how much carbon is being sequestered by our tropical trees. And this helps us when we go for negotiations, especially on the carbon trade market. At least we are able to strengthen our stance and let them know that if our trees are able to sequester this amount of carbon, then we need this amount of money from the Green Climate Fund. Then we are able to receive some appreciable or some significant amount of money that we can use for national development to at least support our road constructions, our housing deficits, and other things, while still protecting our forests and putting them in a very good shape.
Researchers will have free access to the data generated by Ghana Flags. The station will be a national asset to support climate change research and national effort in addressing and reporting on the Sustainable Development Goals. A report by Mohammed Nuruddin.